Hello students, welcome back to the class, and today we will be reading about conductors and insulators. Till now we have read about the electric charges, some properties of the charges, how these bodies are acquiring charges, whether charges are being created or destroyed, and what kind of bodies are said to be electrically neutral. Do they have charges in it or the charges are balanced in it, polarity of charges. So after reading all these things, the one question which is been unanswered so far is like which kind of bodies produce this kind of electric charges and which bodies do not produce, which bodies allows these charges to move from one place to other, and which bodies allow the accumulation of the charges at a single point. So to understand these few concepts, we need to know about the conductors and the insulators. What is a conductor and what is a insulator? Once we are clear with the conductor and insulator, we will get an insight of the charges and how these charges are behaving specifically in specific kind of material. Like if we get a wooden material, there will not be any spark we are going to feel, but if we take a steel rod, we will definitely feel. So what is the difference between a wood and a steel? The only difference is one of the two is conductor and other one is insulator. So starting with the point 1, some substances readily allow passage of electricity through them. Okay, some are extremely ready to allow the passage of electricity through them and others do not. Others do not. Some do allow. So those which allow electricity to pass through them easily are called conductors. Conductors have a property to conduct electricity. Property of conducting electricity. They conduct electricity. Passage. They make easy passage for electrons. Easy passage for electron movement. Okay. Now conductors have electric charges which are free to move inside the material. Now see, this is our conducting material, and in this we have charges which are free to move from here to there. They can move anywhere on the surface. They can come near the surface, can run, can walk, can jog. They can do anything inside this material. They are free. They are independent. Okay, they are free. So metals, humans, animals and earth, these are conductors because they easily allow the flow of electrons through them. Like when we touch something like steel or some other metal while we are getting up in a bus, we feel that electric shock. How? The charges which are being accumulated by our rubbing on the leather seat, we are sitting in a bus or a car, when we touch a body which is conducting in nature, the charges which are on our surface, which are on the surface of our body, start moving to the next conducting body, and from the next conducting body they spread out. So minimizing their area of contact and all, they will spread out. All the charges are away from each other. So for like electrons have a very good speed of motion. So as soon as we touch, we will feel a very small spark and later on it will go off. So this is just a movement of the charges from rubbing of the seats which is accumulated on the humans, and from these humans to the steel or the iron rod which is in the bus or the car. Okay. Now moving to the next point, most of the known metals like glass, porcelain, plastic, nylon, wood offer high resistance to passage of electricity. They do not allow the electricity to pass through them, and hence they are called insulators. Insulators insulate. Insulators insulate. Insulate. What does insulation means? It means do not allow free movement of electric charges. When charge is transferred to conductor, it readily gets distributed over the entire surface of conductor. So this is our conductor and we gave a handful of charge to it, okay, a handful charge of it. What will happen next? These charges will start accumulating over the surface of the conducting body, like they will be uniformly distributed. This thing is known as uniform distribution. Uniform distribution. They will start distributing uniformly. And what happens when we are talking about insulator? If some charges are transferred on an insulator, it stays at the same point. See over here, this is our insulator and we provided a handful of charges to it. What will happen? These charges will stay over here in a group, okay, they will not move here and there. So no free movement of the electric charges happen and hence no uniform distribution. No uniform distribution. This property of nylon and plastic comb gets electrified on rubbing, but a metal article like spoon does not. So from this property we get to know that plastic item gets electrified but a spoon does not get electrified. How it is happening? This is our comb, okay, now we are rubbing it with our dry hair. The charges which are present in the dry hair will start coming here, but as this is insulating in nature, it does not provide the movement of charge and they will keep on accumulating over a surface, over a same surface again and again. So if we are bringing bits of paper near to this surface, these will start attracting towards this charged area. But when we are talking about something metallic, let it be anything, as the book have given example of spoon, we can give example of any other metal, maybe a metallic pen or anything. They do not acquire, like they acquire charges but they do not keep accumulated charges on the same surface, they keep on spreading. So we do not get a lot of sparks out of them, not lot of sparks from them, okay. The charge on metal leak through our body to the ground as both are conductors of electricity. However, a metal rod with wooden or plastic handle is rubbed without touching its metal part, it shows sign of charging. Now we are having a rod which is insulated over here. So and we are providing charges from here. These charges will come at this point and as per to the law they will start accumulating all over the surface, and as there is no chance for these charges to move out of the surface of metal, what will happen? Slowly as all this surface will accumulate the charges, then more charges will start accumulating and slowly more charges will come, and at a point this metallic rod which is insulated at one side will show sign of charging, okay. So let us summarize our conductors, insulators and the third branch of these elements, okay. So we have many elements in our periodic table, okay. Now we have classified all these things according to our requirement, maybe atomic number, mass, their chemical behavior, their physical properties, what not. One parameter to define these elements is their nature. When they are introduced, 2 electrons two charges or two electric field. They are classified as metals, non-metals, and in between, like have metalloids. Okay, metalloids. And from these metals, non-metals and metalloids, similarly another class of classification comes, which classified these elements as conductors, insulators and semiconductors. Now going to the conductors. Conductors naturally allow the flow of electric charges. Naturally allow flow of electric charges, and upon getting charges, distributes them uniformly. Whereas when we talk about insulators, what happens? They do not allow flow of electric charges through them, and when given a handful of charges, they accumulate them there itself. Like if we are talking about this particular body and we gave a handful of charges, these charges will be accumulated over this place instead of moving to the whole surface. Okay. Now semiconductors. As name suggests, they are in between the conductors and insulators. They behave as conductors in special cases, like when we increase temperature or when we dope these semiconductors, these will behave as conductors and will allow passage of electric charges. Okay, so mostly group 13 elements are semiconductors. Make a change. Group 14 elements are semiconductors, and group 13 and group 15, these two groups are used as dopants. Elements from group 14 which behaves as semiconductor are silicon and germanium. Okay, so I hope that you might have understood these conductors and insulators as well as semiconductors. It is very much important to know in which condition the electric charges will show what kind of properties. And for today's class, this was our topic which we have covered. So let's meet in the next class. Bye bye.